A first part scraps. The operator blames the program. The programmer blames the operator, and the part goes in the recycle bin. 9 times out of 10, the program was fine. G54 is a work offset. In plain English, it's the machine's memory of where your part lives inside the work envelope. Without it, the controller has no idea where the part is, only where the spindle is. Every CNC has 2 coordinate systems running at once. Machine 0, set by the manufacturer, lives at a fixed point, and part 0, set by you, lives on the workpiece. G54 is the bridge between them. That bridge is just 3 numbers, X, Y, and Z, distances from machine 0 to the corner of your part. The control stores them in a register labeled G54. When your program reaches a line like this, the control reads the G54 register and shifts the entire coordinate system to your part. Every X and Y after that is measured from the corner you picked. To set it, you touch off. Edge finder, probe, or a piece of paper against the side of the workpiece. Anything that tells the machine exactly where the part begins. You jog to the X edge, hit a button, the control records the position. Y edge, record. Z, usually the top of the part. 3 captures, and G54 is alive. Here's where it goes sideways. The edge finder has a radius, the probe has a radius. If you capture the edge without compensating for that radius, your G54 is off by exactly that amount. Usually a tenth, sometimes 10,000ths. Forget to add that radius, and the first part scraps before the second tool change. Most operators were never taught to verify G54 before cycle start. They trust the touch off and hit green. The programs that survive in busy shops are the ones where someone built a verify step into the routine. A single block air cut, a dry run, anything. G54 isn't alone. There's G55, G56, G57, G58, G59. 6 standard work offsets on most controls, more on newer ones. Each one is a separate part location stored in its own register. Running 4 parts on a fixture plate, G54 for part 1, G55 for part 2, and so on. The program calls each offset when it's time to machine that part, and the control shifts coordinates on the fly. In code, switching offsets is literally 1 line. The control reads the new register, the coordinate system jumps, and the same machining moves now cut a different part. The 3 failure modes are almost always the same. 1. Edge finder radius forgotten. That's the 10th off everywhere scrap. 2. Z set on the vise instead of the part top, which sends the tool a full part height too deep. 3. G54 left over from yesterday's job. A new part goes in the vise, the operator forgets to retouch, and the machine happily runs a program against numbers that have nothing to do with the part in front of it. Before every cycle start, walk through 3 checks. Does G54 match this part? Did you compensate for the probe or finder radius? Is Z set to the surface the program expects? 3 questions, 30 seconds, 0 scrap. The shops that scrap the least aren't the ones with the best programmers. They're the ones where verifying the work offset is a non-negotiable part of setup, same as deburring a fixture or checking tool length. If you've made it this far, you already understand G54 better than half the people running it. Subscribe. ShopFloorIQ does plain English explainers for the codes, alarms, and habits that decide whether the part on the table is a finished part or a paperweight.